Cloud computing lets programmers tap into the virtually unlimited processing and storage power of vast data centers run by Amazon, Google, and others. But programmers are finding it hard to manage data within a cloud, restricting their ability to develop entirely new types of applications that could take advantage of a cloud's ability to quickly manipulate huge amounts of data. TR10 innovator Joseph Hellerstein is trying to make life easier for programmers by creating tools that can take over data management within a cloud. We asked him about the potential of cloud computing and how his approach will unlock that potential.
Well, the state of the art right now with clouds is you're sort of programming one machine at a time. And that doesn't really take advantage of the power that's there. If you've rented 1,000 machines from Amazon, what you'd really like to do is coordinate those 1,000 machines to do something that's 1,000 times more powerful than you can do on a single server. Well, today the cloud, if you think of it as a new platform, is underexploited. I think of the cloud the way I think of the PC or the iPhone, as a new platform to enable programmers to do creative things. And the great thing about a new platform is for programmers to take advantage of its particular capabilities. In the case of the cloud, those capabilities are ubiquity, it's everywhere. And power, there's thousands of machines back there that the programmer can harness. And until we enable programmers to harness that power, we're really not taking advantage of this new platform. So our goal is to enable that kind of programming. So the simple idea was to take a problem we know how to solve and use it to attack a problem that we consider to be hard. So the hard problem today is coordinating a program across hundreds or thousands of machines. But a simple problem that people do know how to solve is how to analyze big data sets. And they do this with languages like SQL and MapReduce. Now, when people program SQL or MapReduce programs, they don't think about parallelism. They just think about a data-centric task. We're trying to take that idea and apply it to general purpose programming to get people to program all kinds of software in this data-centric fashion that's easy to parallelize. So to validate this idea today, what we've gone ahead and done is build some cloud infrastructure in this style. So we went ahead and we re-implemented the Hadoop file system from scratch in a prototype version of our language, as well as part of the Hadoop MapReduce engine. And we were able to show that we could do that very easily, with much less programmer effort and with significant extensions to the code that's out there today. Going forward, what we'd like to see is programmers with creative ideas inventing things we haven't even dreamed of. That's the goal of writing a new programming environment and programming language. So in my group here at Berkeley, we're looking at sort of data-centric problems in the large, and I break that down into two pieces right now. One is how do you build and architect the systems that are going to allow us to have computing environments that are much more powerful than we have today. So that's a software engineering and programming languages problem, and we take a very data-centric tack on that. The other is actually the analysis of very large data sets, both the statistics involved, the scaling of the systems, the visualization and human effort involved in that, and how do you get groups of people to do sort of social computing on big data. And these are efforts that I do in collaboration with other faculty here at Berkeley, with my graduate students, and with collaborators in industry.